there's a rich history behind this. It goes like this.
The first planes were launched from ships in 1910, just 7 years after the Wright brothers' maiden flight. Wooden platforms were built onto the gun turrets of large cruisers. Takeoff was hazardous. And there was nowhere to land. The pilots had to ditch in the sea and wait to be rescued. Seaplanes proved more practical. They landed on the sea and were lifted back on board. The British used them as reconnaissance airplanes in World War I. They were a decisive factor in the great North Sea naval battle of Jutland. In 1922, the U.S. Navy launched its first full-sized carrier. The Langley was converted from a coal ship with its flight deck built up.
Yeah, in a catapult shot, you do about 0 to 140 in about a second and a half. So it's quite a shot.
It's like driving a rocket. It really is. Especially when you get shot off a boat. It's the best amusement park ride you're ever going to get on.
But for all pilots, launch is a moment of extreme danger. When things go wrong, they must be ready to react instantly. When this plane went out of control, the crew had only a split second to jettison the bomb load and eject.
Okay, so I got a question for you. So these...
The John C. Stennis has 4 steam catapults, which together can launch planes at the rate of 3 a minute.
3 a minute, guys. It's 0 to 140 miles per hour within 300 feet. How long would that take?
Yeah, in a catapult shot, you do about 0 to 140 in about a second and a half.
This guy says it takes about a second and a half. Is that correct? All right, so let's run the numbers on this one. So what do we have? We got 300 feet to go from 0 to 140 miles per hour. All right, so the first thing is figure out the acceleration and then figure out the time it takes to reach that speed. All right, so the initial speed is going to be 0. Final speed is going to be 140 miles per hour. 300 feet is the runway. So the question is the acceleration, and then get it, all I had to just express it in terms of G's. All right, conversions miles per hour to meters per second, feet to meters. All right, so we'll carry out the conversions. All right, so crunch the numbers. Okay, good. Okay, next step is find the formula. Which one should we use given these symbols? Would you use the first one, the second one, or the third one? What do you guys think?
Third.
Okay, yeah, the third one is the one that makes sense, right? Because time is not given to us. The third. All right. So based on those symbols, use the third one. All right, so we'll pick that one and go to work. All right, if you have any zeros, just plug in the zeros to simplify it. So the initial speed is 0, so this term is going to drop out. And so we'll get rid of 2 and get rid of x. And now use the numbers in metric units only. All right, so speed squared divided by 2 times x. So it's going to give us the acceleration. All right, the next step is just express it in terms of g's. So we end up getting 2 g's roughly. So it's about 2 g's.
Do you leave it there for a second?
No, Christian. This is being recorded, so you can watch it later. Okay, the lecture is kind of timed. All right, also you will get the handouts later, so just relax and watch it. I want you guys to get the concepts. The math is something that you kind of have to work out for yourself. And busy work is something that you guys do on your own. All right, so the next one is now, it's 2 Gs, right? Okay, and they're using a catapult, and it's based on the nuclear power generator, so they probably have enough power. That's gonna last them like a century. That's not a big deal. And they're able to launch 3 fighter jets a minute. So why not? It's 2 Gs, guys. They're wasting 300 feet of space. Why not make it like 100 feet so you can actually launch, say, about 20 a minute? Why not make it like 2 feet so you can launch maybe about 100 a minute? All right, so why not make it about a foot so you can launch maybe about 500 a minute? Guys, imagine that you can launch like 500 airplanes a minute. Okay. You can eradicate terrorism within days. It's not like a big deal. We can attack every single country on earth. Imagine the surprise of Canadians when we start dropping bombs on. All right, that'll teach them a lesson. All right, ignore the politics of it right now. Why is it that they would not take these airplanes from 0 to 140 miles per hour within, say, less than a foot?
The whiplash?
The whiplash, is that the worst that can happen? Guys, what do you suppose is going to happen to you if you were to go from 0 to 140 miles per hour within a distance of, say, about a foot, 10 inches or something? You know, you can be exposed to up to 140 Gs and be able to survive, right? what would happen if I were to accelerate you at a rate of 100 Gs from 0 to 140 miles per hour? What do you think is going to happen?
Your plane is going to fall apart.
I don't care.
The pilot
Ignore
will black out.
The pilot is going to black out. That's not the worst that can happen. If I were to take you from 0 to 100 miles per hour, you're looking at broken bones, internal bleeding, that sort of stuff. Is that a good idea to have a pilot bleeding internally with broken bones? No, guys, it's not going to work. All right. So do you understand why they make it 300 feet? That's 300 feet because it's 2 Gs. It's enough to get your attention. In a sense that, no, you're not going to be distracted. You're not going to be texting. You're not going to be drinking your coffee. 2 Gs is good enough for you to be able to actually control the airplane if something goes wrong. All right. That's the reason why that's what they use. All right. So notice that every single pilot is going to experience the same 2 Gs because it's uniform. It's set. This acceleration is predetermined, which means that the motion is made highly predictable. So the next question is, how long would it take for you to clear the deck? How long would it take for you to clear the deck? All right, so what do we do for that one? Okay, so notice that now we're looking for T, and then this equation has T in it, so is this one. So we've got 2 options. Okay, either one will work, guys. Either one is going to work. All right, again, if you want to do it the lazy way, and that's the way I'm going to do it, I'm going to pick the second equation. So pick the second equation. All right, so it looks like that. Solve for T. Initial speed is going to be 0, so I'm going to drop that. And then divide both sides by A, and that's it. All right, so that's it. Okay, so the next step is just plug the numbers in. All right, so this gives you about 3 seconds. All right, so how long does it take for you to actually clear the deck? It's going to be 3 seconds. How long does it take? 3 seconds. How long does it take? 3 seconds. Well, it takes you 3 seconds to actually clear that distance.
The John C. Stennis.
Yeah, in a catapult shot, you do about 0 to 140 in about a second and a half. In a catapult shot, you do about 0 to 140 in about a second and a half.
Does he not know? What do you think?
Yeah, in a catapult shot, you do about 0 to 140 in about a second.
You don't think he knows his numbers? He knows it's 3 seconds. I know it's 3 seconds. And he's exaggerating. Is there any reason for exaggeration? Absolutely not. What these people do is impressive enough, but they're so competitive that they still want to exaggerate. On top of that, and then they become recruiters. And they start lying about this and that. So that's kind of interesting. So my question to you is, which ones are better liars, politicians or recruiters? What do you guys think? Let's talk about psychology.
Yeah, in a catapult shot, you do about 0 to 140 in about a second and a half.
Sexual relations with that woman, Miss Lewinsky. I never told anybody to lie, not a single time.
In about a second and a half.
I never told anybody to lie.
About a second and a half.
I never told anybody to lie.
About a second and a half.
I never told anybody to lie.
A lot of people think that politicians are better liars. In reality, it's not true, guys. The recruiters tend to be much better because they keep telling the same lie over and over again. They're not really emotionally attached to what they're saying. Notice that here, Clinton is very attached to what he's trying to say. He's lying. It's fairly obvious. It's got the postures of a liar, in essence. All right, pick out the best answer, and then put your answer on the side. Okay, very good. I'm seeing a lot of A's. Okay, so the only thing which is not changing in time is acceleration, right? If the acceleration is constant, that's the only thing that doesn't change in time. Okay, velocity is going to change, this is going to change. And velocity at any given location is going to change. Very good. So give yourself 5 points for that one.
But for the ultimate in power and speed, nothing beats top fuel dragsters. These cars couldn't take you to the corner grocery store or even negotiate the neighborhood cul-de-sac. But no other car can touch them when it comes to straight, gut-wrenching acceleration. Along with funny cars, top fuel dragsters are the fastest race cars on Earth. Both repeatedly cover a quarter mile at speeds in excess of 300 miles per hour.
These cars go 0 to 100 in 1 second, and they pull 5.5 Gs, which is more than the space shuttle at takeoff. And it's a great ride.
Meet Shelley Anderson, a nitro-breathing woman with racing in her blood. Anderson has won 4 top fuel national events and became the fastest woman on wheels when she claimed the speed record in 1997, flashing down the track at an astounding 317 miles per hour.
All right, let's get back to her.
But for the ultimate
in 1 second, these cars.
All right, guys, just remember this. If you're on TV throwing numbers around, and if I'm watching you, I will always check your numbers for whatever reason. All right.
Go 0 to 100.
So she said 0 to 100.
1 second.
1 second.
And they pull 5.5 Gs.
5.5 Gs.
Which is more than the space shuttle at takeoff.
More than a space shuttle at takeoff. Do you think she is lying? She's making 2 statements. She's saying going from 0 to 100 is 5.5 Gs. And that's more than the space shuttle can take off. Do you think she lied twice in one single sentence? Or do you think she lied once? Or do you think she didn't lie at all?
And it's a great ride.